Good morning, all. Today is our second Arduino practical, right? During the first day, we discussed about basics of Arduino board and the Arduino software, that is Arduino IDE. And also we discussed about input of the Arduino Uno board, right? You know that the Arduino board is connected to the computer through the USB cable, right? There is a method to send a message from Arduino board to computer. You know that when we program in, what happened, the program created in the computer is sent to the Arduino board through this cable, right? So this cable can be used to communicate with the Arduino board and the PC. Okay, so there's another way. By using this cable or this USB connection, or this is actually called serial communication. By using serial communication, we can send a message from Arduino board to the computer. So first I am going to show you how to do it. So I'm going to share my screen. Still Arduino software is loading. We have to wait for the Arduino software. Right now Arduino software is on. Right, yes, I instructed you to develop a nitride circuit, right? Can you remember? And you have to upload those photos and all. Later I will put them into the link, right? And I'm going to a new file, right? අර මේ සාමාන්‍යයෙන් වැඩ පටන් ගන්නකොට ඉස්සෙල්ලා මේ sample code එකක් දාලා බලන්න whether everything is okay. So what you can do is you can go to file, just look at file, examples, file, usually we new file, you can go file, examples, then there are a lot of examples available, right? So under the basics you can find item called blinks, right? So this is the blink program. So it is actually the program that we developed to blink the pin number 13 LED, right? Tools, Uno board is selected, port is selected. So you can just verify whether code is working. And you can upload. Done uploading. Now my LED is blinking. That means I know my setup is okay. At the beginning, always you have to upload a simple program to the board and see whether everything is fine, right? Then we can do anything else. So I'm going to explain how to send a message from your computer to the Arduino board. There's a function. There's a function called print. There's a function called print. and you can put anything. I say hi, hello computer. You are going to say hi or hello to the computer. Okay, with this, uh, actually this is serial communication, therefore you have to put serial.print. Okay, serial.print, and you can send the hello computer to the computer by using this command. There's one more thing. You have to put special command at the beginning. I will explain what is it, right? So we'll see what happened. I will explain the first command. Now this code is saved. And program is uploading. Compiling sketch. Uploading is done, right? So under the tools, you can see something called serial monitor. All of you, under the tools, there is something called serial monitor. There's a shortcut here too, right? Top right hand corner, you can find this shortcut serial monitor, either using tools serial monitor or by using this serial monitor icon, you can open the serial monitor. So you can see something like this. This is called serial monitor, right? That means it's like computer monitor. You can monitor the things. That's why it's called monitor. Computer monitor. So you can see the hello computer is on your screen. If I press the restart button of the Arduino board, I'm going to press the restart button of the Arduino board. Then you can see that hello computer is appeared again. Hello computer is appeared again, right? Uh, Here what happened is, I will put this into uh, control. I will put it into the loop. Then what happened? You know that it will repeat again and again. You can see hello computer is repeating. I will put one more modification. LN stand for line. I'm going to say print line. Print line. Okay. You see the serial monitor now. You can see that it is printing downward direction. Printing downward direction. That means the program is running the Uno board. Once the program is run, the program send hello computer to the computer, something to the computer. Okay. I will add more things. Let's say there's a variable, integer variable a. Okay. A is 1 at the beginning. Okay. So I'm going to print serial print. I'm going to print a. Okay. Semicolon. Put a space here. And here a equals a plus 1. And put a delay of 200 milliseconds. Okay. And see what happens. So I have to open up the serial monitor. You can see that 21, 22 likewise. And hello computer is also printed. So print means we are printing to the screen. What we are printing? We are just printing a to the screen. Now value of a is 1 at the beginning. Then hello computer is printed. Value of a is printed, and after that hello computer is printed, right? Then a is equals a plus 1. No, that means a is increased by 1. එකයි ඔය දැන් 191 192 එහෙම තියෙන්නේ එකයි. A is increase, then wait for a moment, right? දැන් මේක අපි අඩු කරන්නත් පුළුවන්. We can neglect the delay. We can neglect delay, right? Then you can see uh, this will be very fast now, right? You can see that almost 100 lines were printed. You can see how fast the Arduino board is. So I will explain this again. There are two types of prints. Okay, the print A means just A is printed. When it is print line, that hello computer is also printed and go to the next line. දැන් අපි මෙතෙන්ට මෙහෙම print කියලා විතරක් දැම්මො. This is not the print that we use in Python. That's a difference. Okay, අපි print කියලා දැම්මොත් ඊළඟ line එකට යන්නේ නැහැ ඒකයි. බලන්න. දැන් ඔක්කොම print වෙන්නේ same line එක. Therefore, if you want to go to a next line, you have to use println. Okay. So this is called serial communication. This is called serial communication. So better to have some delay here, right? So if you want to use this USB cable, and if you want to connect with your computer, we have cable and all, no? So but you have to use this function, begins function. If you only use begin function, then you can communicate with the computer, right? I will explain what is this value later, right? I will explain this value 9600 later. So that is the speed of the communication actually, right? So we are going to communicate, we are going to send data from computer to the Uno board, from computer to the Uno board. That's what we are going to do, right? We are going to start that communication. That's why it says begins. හරි මේක පොඩ්ඩක් try කරන්නකෝ බලන්න. අර tools වල තමයි serial monitor කියලා තියෙන්නේ. හැමෝම මේක try කරන්න බලන්න. I will copy down the code and put it into the chat too. කරලා බලන්නකෝ. Hope that you are doing right. You can make changes and see, right? හරි ගොඩයි ස්ටේටස් එක අප්ඩේට් කරන්නකො ළමයි. Right. Here is the coding of our last program. You can remember that color light example. In this case, TX LED is also blinking, right? TX LED, TX or RX. Look at the board. TX LED is also blinking because we are transmitting data from Uno board to computer, right? Each time when you transmit, you can see that. Right. Another thing is that think about last program. This is what is called that traffic light example, right? So if you want to look at your status, in other words, if you want to print, you know, in Arduino programs, in Python programs, we use print function. When we use print function, what happened? It is printed on what is put into the print is printed on the screen. Similarly, so Uno, this is a Uno board. So Uno board is it's a computer, but it is not advanced computer like your computer, right? There is no any monitor to the Uno board, but still you can use your computer monitor as the monitor of the Uno board. That's the basic idea behind here. Monitor of your computer can be used as the monitor of the Uno board with the print function. So what you have to do is you have to start with the serial dot begins, serial dot begin 9600, right? I will explain what is this value 9600. Anyway, here what we do is we just start the communication. There's a hardware link between your computer and the Uno board through the USB cable. This is the hardware link, no? So hardware link is not sufficient. We have to establish software link, software connection. That is the purpose of putting serial.begin 9600, right? And you can put uh, serial print line. Put something setting up the color light system or something like that.
Oh, teacher,
setting up the color light system. අපේ room එකේ classes දෙකක් යනවා, right? එකක් ඔයාලගේ class එක අනිත් එක අපේ grade 1 class එකක් යනවා. ඉතින් පොඩි සද්දේ ගණන් ගන්න එපා. look location දෙකක කරන්න ගියන් පස්සේ මට කරදරයි හින්දා අපි මෙහෙට ගත්ත කට්ටිය. setting the color light system first. Set up. Okay, and here you can put the state serial, just to see, no need to do this, right? Serial dot print you can put go print line go කියලා දාමුකෝ එතන serial. Here what happened is the next what you're going to do is wait state. So we can put wait here. Likewise, here we can put stop. So what I'm going to show you, with any program that we have, we can use this concept. Stop. Then ready. Ready when not ready කියලා දාන්න. Ready. Okay, I'm going to upload this code and look at the serial monitor. You can see that go after 5 seconds of go time, we have to move into wait, stop, and after 3 seconds, I think we have to come back to ready. So you can see all these things in the screen now also, right? So here basically what we did was there is no any there is no any monitor to your Uno board. There is no any monitor. There is no any monitor means we can't take we can't take prints. We can't take any output from your Uno board. Only LEDs can be connected. Later you can connect some other displays, but at the moment there is no any display. So we can use our existing computer monitor or your mobile phone monitor. If you are using the mobile phone monitor has an as a monitor to your Uno board. Okay, again we'll see. So here 9600 is the speed. Okay, so you are writing this program and uploading it to the board. No, that means the board, the direction of board, the speed is set to 9600 in the board speed is now 9600, right? So in the serial monitor also, you have to, if you look at the right hand bottom right hand corner like this, you can have various speeds here. This is speed, name of this speed is baud rate. For example, if I put a different value, 2400 or something like that, then you can see what happened. Can you see? Some questions were displayed. Clear? Some questions. Because both side must be in the same speed. The typical speed is 9600, but you can use any speed, right? Typical speed is in the Uno board, we have set the speed to 9600. In your computer, also you have to set the same speed. You have to set the same speed. Okay. Right. With that, we are moving to inputs. So last time we discussed how to use the uh, digital port of the Uno board as an output. So today we are going to learn how to use digital port as an input. Okay. So I'm going to take a new sketch. All of you look at. So I'm taking new sketch. So what I'm going to do is I'm going to use digital port 7, digital port 7 as an input, right? But here I am going to use a special input situation. It is called input pull up. I will explain it. What is it exactly? So if you are using any digital pin as an input, right? If you are using output, you have to set the pin mode as an output. No, now we have set it as an input. Okay, we will start, right? Suddenly I have to go to this school, that's why. So what we did was we set pin number 7 as an input, right? You can remember digital write that we used last time. Similarly, there's another function called digital read. If it is a digital write, what we did was to pin number 7, then you have to put high or low here, high or low. But this is not the write, this is read function. In read function, you have to put the pin that you want to read. For example, in this case, pin number 7. Then you have to assign into a variable. For example, variable A, right? So when it is a variable, you have to initialize the variable at the beginning, right? When you read, the value can be one of the two values, where it can be either low or high actually, right? Therefore, well, it will be 0 or 1, right? Therefore, you have to use int A. So A is an integer variable. So value of A will be either 0 or 1. Okay. But if you run this program, you can't see anything. So what we have to do is we have to print this value serial. We are going to print this value to the screen. So if you're using screen, you have to use serial dot begin at the beginning. Then only serial communication start. Now it is start at speed of 9600. Anyway, we don't want to do this very fast, so I'm going to use a delay of 100 milliseconds. Okay, shall we try this program first? මේක කෝඩ් කරගන්නකො බලන්න අපි රන් කරලා බලමු ඊට පස්සේ Hmm? Okay, look what I'm going to do. So I have upload this program. Look at, we are using pin number 7. Just look at, we are using pin number 7. What about line mom? So this is pin number 7. I have to take a jumper wire, and end of the pin number 7 is one end of the jumper wire is connected to pin number 7. Okay, and the other end is here. So if you look at that at the same time, if you look at the serial monitor, at the same time, if you look at the serial monitor, everybody look at, now you can see the serial monitor's value is 1. So if you connect these two, if you connect the other end to ground, that means pin number 7 is connected to ground now. You can see that when you connect the pin number 7 to ground, then it will be 0. If you release it, it will be 1. If you connect it to the ground, 0. If you did not connect, it will be 1. Actually, there are two types of inputs, just the ordinary inputs and input pull up. මෙහෙමත් පුළුවන් නිකන් input කියලා විතරක් දාලා මේක කරන්නත් පුළුවන්. Then there is an issue. I will explain that one too. If you look at the serial monitor, when you connected it to ground like earlier, ground එකට connect කරාම ඉස්සෙල්ලා වගේ 0. But when you release it, it can be 1 or 0. But if you connect it into 5 volt, it is 1, right? Normally we have to use input pull up, input pull up, right? Then what happened is input is set to up. Input එක නිකම්ම up වෙලා තියෙන. එහෙම මේ input එකක් දීලා නැති වෙලාවේදී 1 විදියට තියෙන. නැත්නම් up වෙලා තියෙන. ඒකයි input pull up කියලා කියන්නේ. ඒතර අපි ඒක ground එකට connect කරොත් මේ විදියට ground එකට connect කරොත් තමයි 0. I can see in the first picture. හරි මේ විදිහට තමයි අපි සාමාන්‍යයෙන් ඉන්පුට් එකක් ගන්න. අපි දැන් මේ ස්විච් එකක් දාන්න හදන. You can find your all of you look at the screen. You can find your push button switch එක. So it can be connected to the two rows of the board, right? So I have connected to the first row and the third row. Usually it is difficult to connect the first row. So one side of the switch is connected to the digital pin 7 and the other side is connected to the ground of the Uno board, right? Now what happened when I press the switch, when I press what happened, the pin number 7 is connected to the ground. That means value will be 0. If it is not connected, value will be 1. මෙන්න මේ විදිහට switch එකක් දාලත් ඔයාලට වැඩේ බලන්න පුළුවන්. එතකොට අර wire එකකින් connect කරන්න බැහැනේ. wire එක කෙලින්ම connect කරන්න නෙවෙයි අපි switch එක තමයි පාවිච්චි කරන්නේ. When I press 0, when I usually it is 1. If we press, it will be 0. Try to connect a switch. Switch එක දාලා බලන්නකෝ. So this is how we connect the switch to the Uno board. Okay, I have muted, right? All of you. We are going to do another program. So what we are going to do is we are going to use inbuilt LED, which is connected to pin number 13, no? Pin mode 13 output, and digital write 13. What I'm going to write is just A. What is A? A is the value of the switch. A is the value of the switch. Okay. So I just upload this. Okay. And I'm going to switch the camera. Switch the camera. I can see that now inbuilt LED is on because I did not press the switch. No. If I press the switch, it will be 0. Right. Now you can see that when I press in the switch, LED is off because the value written to the LED is 0 now. Make a release kara 1 වෙනවා. Here we have put a delay now, right? ඉතින් පොඩි වෙලාවක් යනවා ඒ delay එකත් එක්ක, but When you press, input value goes to 0, therefore LED is off. Right, still there may be some issues, don't worry, all of you. I'm going to add a few modifications here. Just look at, then we can reach to the final code. So I'm going to use if-else situation now. So here what happens is when you switch on the LED, when you press the button, LED off no. Look at what I'm going to do now. Okay. අර සීරියල් එකෙන් වෙන්නේ නිකන් බලාගන්න එකනේ. හරි. මේකෙන් එන්නේ බලාගන්න එකනේ. වැලියු එක බලාගන්න එකනේ. හරි. If I'm going to use if else situation. If within a bracket a equals 0. A equals 0 means switch is pressed now. So what I want to do is, if the switch is pressed, I want to set the LED to high, else digital write. If else madagani digital write 13 to low. If you want, you can change high low. මෙතන මේ if else එකක් දාලා තියෙන්නේ. දැක්කද? It's an if else situation. This is the first if else situation that we are going to use in this course, right? In the C language. Now see what happened. Code එකෙන් ඕන එකක් වෙනස් කරගන්න පුළුවන්. දැන් බටන් එක press කරලා නැහැ. LED go off. දැන් බටන් එක press කරනවා. බටන් එක press කරාම තමයි on වෙන්නේ. Button press. If you press the button, LED is on, off, on, off. Switch එක switch වල පොඩි ප්‍රශ්න තියෙනවා. You have to press it ටිකක් තදට press කරන්න ඕන. So this is the first if else situation that you are going to use here. මම බලන්නකෝ කරන්නකෝ. code එකත් screen එකේ දාලා තියෙනවා if else එක. ඔයාලම type කරලා බලන්න. logic එක වෙනස් කරගන්න පුළුවන්. මෙතෙන්ට ඕන නම් 0 නැතුව 1 දාන්නත් පුළුවන්. if else එක කරන්න කල් ඉවර වෙලා මට කියන්න. හරි. ඔයාලටම කෝඩ් එක try කරලා බලන්න. type කරලා බලන්න. So you can change the logic, right, in the way that you like. Switch එක press කරාමද නැද්ද කොහොමද වෙන්න ඕන කියන එක අනුව. අනිත් කට්ටියත් පොඩක් ස්ටේටස් එක අප්ඩේට් කරන්න. අනිත් කට්ටියත් ස්ටේටස් එක අප්ඩේට් කරන්න. කට්ටිය ස්ටේටස් එක පොඩක් අප්ඩේට් කරන්න. Right. Okay, all these things are under the practical sheet 1, right? If you look at the practical sheet 1, then you can find all these things, right? Next, what you are going to do is, now we know how to use the digital port. We use digital port input as well as output, right? Then we are moving to the analog port. Analog. Okay, එකත් අපි කරලා analog එකකට ගිහිල්ලා ඊට පස්සේ අපි break එකක් ගමු. මේ බලන්න මේ analog එකේ ගහලා තියෙන්නේ මොකද්ද කියලා. analog විතරක් නෙවෙයි නේද, තව මොකද්ද ගහලා තියෙනෝනේ. Yes, analog in කියලා තමයි ගහලා තියෙන්නේ. That means you can only use analog. This is not for both analog in and out. This is just for analog in only. Okay. එකෙන් ගන්න පුළුවන් in විතරයි. input විතරයි ගන්න පුළුවන්. output ගන්න බෑ. input එකක් විතරයි ගන්න පුළුවන්. එතනින් output එකක් ගන්න බෑ. analog input විදිහට තමයි use කරන්න තියෙන්නේ. හරි. අපි දැන් sketch එකක් ගන්න හදන්නේ මේ analog එකත් එක්ක වැඩ කරන්න. Right? So if you are using analog port, it is not necessary to use pin mode. Why? It is not necessary to use pin mode. Why? Hi. No need to use this. No need. Why? Because analog is only analog in. Look at, I'm going to share the screen. Now we are going to use the analog now, right? Because analog is your, we don't have to use this pin mode function. No need to use pin mode. So you can directly use analog read. Analog read, for example, we are going to read the first analog one, analog 0 කියන එක තමයි 0 to 5 නේ තියෙන්නේ මෙතන. හයක් නේ ඔක්කොම තියෙන්නේ. We are going to use analog 0. So there will be a value, no? There will be a value. Let's say variable called value. That variable is integer variable. මම x කියලා දාන්නම් කොලේසියට. ඒතර අර read කරපු value එක තමයි x වලට එන්නේ. Then I am going to write it. Serial dot print line. By using serial dot print line, I'm going to print it to the screen, and we are going to do it after each 200 milliseconds. So I'm going to use serial monitor. Then we know serial dot begin. Let's speed. දැක්කද බලන්න ඔක්කොම දේවල් functions base කරගෙන තමයි කරන්න තියෙන්නේ. And I am going to upload this program. I'm going to upload this program. Okay. And with the serial monitor, I'm going to look at the values. Now you can see that there are some random values. There are some random values for x. Because at the moment, I didn't connect my analog port, analog 0. මේ analog 0 එකත් එක්කනේ අපි දැන් වැඩ කරන්න හදන්නේ. මේ switch එක නම් මම ඔක්කොම අයින් කරමුකෝ. Initially I didn't connect it into any device, right? මම බලන්න මෙතන බලන්න හරි මෙතන මම කරන්නේ දැන් මේ ඇනලොග් පෝට් එකනේ යූස් කරන්නේ ඇනලොග් 0 එකනේ අපි රීඩ් කරන එකට මෙම ජම්පර් එකක් කනෙක්ට් කරලා ඒකේ අනිත් පැත්ත ග්‍රවුන්ඩ් එකට කනෙක්ට් කරනවා පවර් තියෙන මෙතන එතනින් ග්‍රවුන්ඩ් එකට කනෙක්ට් කරනවා ග්‍රවුන්ඩ් එකට කනෙක්ට් කරන්න පුළුවන් ඊට පස්සේ 5 වෝල්ට් වලට කනෙක්ට් කරන්න පුළුවන් 3.3 වෝල්ට් වලට කනෙක්ට් කරන්න පුළුවන් අන්න එහෙම එක එක ඒවාට කනෙක්ට් කරන එක තමයි කරන්නේ okay at the same time I am going to observe the output of the serial monitor now if you connect it to the ground එකට connect කරාම you can see that 0 this is an analog situation no? If you connect it into 5 volt you can see the largest value 1023 right it does visit if you connect it to 3.3 it will be 600 something right they can මෙහෙමයි අර voltage එක නෙමෙයි මේක එන්නේ So what you can see is just not the voltage. It is just a series of values. A series of values. The value range is 0 to 1200, 1023, right? When the voltage is 0 volt, when the voltage is 0 volt, it is අපි 0 වලට කනෙක්ට් කරාන් පස්සේ තමයි අඩුම වැලියු එක එන්නේ. ඒක එන්නේ 1023. When you connect it into 5 volt, it is 0 means 0. When you connect it to 5 volt, it is 1023. That's how the value range varies. Okay, you can try this sketch එක දාලා analog 0 එක නේ analog 0 එක ඔය පැත්තේ තියෙන power port එක එක එකට connect කරලා බලන්නකෝ. These values can be vary from time to time. يعني සමහර වෙලාවට 2023 මෙන්න නැතුව පොඩ්ඩයි කිට්ටු වගේක් එන්න පුළුවන්. 3.3 කිව්වට 670 වගේ වැලියු එකක් එන්නත් පුළුවන්. මේ අපි x කියලා කියන්නේ මේ වැලියු එක. x කියලානේ අපි ගත්තේ. බලන්නකො කරලා ඉවරනම් කියන්නකො. So you have to turn to practical number 13. 13 එකේ පළවෙනි පිටුව ගන්නකො. ඒකේ තමයි මේ ටික තියෙන්නේ. and මේ ස්කේල් එකත් පොඩක් එතන ඇඳ ගන්න. ඡන්දෙත් දාන්න. ඔල ප්‍රැක්ටිකල් ෂීට් එකේ මම පොඩි ඉඩක් තියලා තියෙනවා. එතන මේක පොඩ ඇඳගත්තා හොඳයි. You have to turn to practical 313 එකේ third page එකට යන්න ඕන. third page එකට යන්න ඕන. මෙන්න මේ වගේ practical 13 එකේ third page එකට යන්න ඕන. එතන තියෙන practical number 5 කියලා. ඒ ඉස්සරහින් මේක පොඩක් ඇඳ ගන්නකො. So turn to the practical number 5 in the practical number 13. 13 sheet එකේ practical 5 කියන තැනට යන්න. එතන පුළුවන් ඔයාලට මේක හොයාගන්න. එතන ඉස්සරහා මම ඉඩ තියලා තියෙන්නේ කෝඩ් එක ඉස්සරහින්. කෝඩ් එක පොඩ්ඩක් අඳින්න මෙතන මේ මම මේ කෝඩ් එක ඉස්සරහින් මේක පොඩ්ඩක් මේ වගේ ඇඳ ගන්න. ඒ 0.5 volt වෙනකොට තමයි 1023 වෙන්නේ. When the A0 voltage is 0 volt, this will be 0. Right. Then we are moving to voltmeter practical. Voltmeter. Voltmeter එකට යන්න හදන්නේ. බලමුකෝ මොකක්ද ඒ කියලා. So we are going to make a voltmeter. Okay. So you know that this x value, if you divide this x value by 1023 and multiplied it by 5, then you can find the actual voltage. Whether පහක් තමයි 0 to 5 තියෙන එක තමයි 0 to 1023 කරලා තියෙන්නේ. Therefore we can find the actual value by using this equation. I think it is clear, right? මොකද x එකේ 1023 කියන්නේ y වල පහක්නේ. And then if you print this y value, අපි මෙහෙම කරමුකෝ. Serial dot print, it is print, okay, print x. In Python always you, in C language always you have to use double quotes, right? I'm going to put a space, then y value. මේක තේරෙනවනේ. x print වෙනවා, space එකක් print වෙනවා, y print වෙනවා. See, but there will be an issue. Some y, we have to introduce y. Okay, we have to introduce y, and there's an important thing. For division, always you have to use floating point variable. This is not C, this is not Python, this is C language. C language always for division you have to use the floating point variables. Therefore, otherwise calculation is not correct. Okay. Now see. Now you can see x as well as y. X 1023. At the moment x is 1023 because I have connected it into 5 volt. X is 1023. That time voltage is 5 volt. I'm going to change it into 0 volt, then 0. I'm going to connect it into 3.3. 3.3. Like 3.3 කියලා පෙන්නනවා. ඒ විදිහට අපිට පුළුවන් අර actual voltage එක ගන්න. Actual voltage එක ගන්න පුළුවන්. හරි? හරි එහෙනම් okay. කරලා බලන්නකෝ. Okay, here I have to mention this some special thing, that is the uh, we have to use the plots, right? Floating point variables. We have to use the floating point variable. Plot use karan on. If you are using division, you have to use the plot. Right. One more thing. You can remember variable resistor. Variable resistor. Matagayne. Arakawan puluang. So with this practical, we are going to use variable resistor. Okay. So I'm going to connect the variable resistor to the breadboard. Breadboard connect. So middle of this pin, middle pin is connected to the analog pin. Middle pin. Middle voltage middle resistance that is connected to the analog pin 0, right? Other two pins, one is connected to 5 volt, one is connected to 5 volt, and the other one other one is connected to the ground, 5 volt and ground. Okay, එතකොට මේක වෙනස් කරන්න පුළුවන්. Then the middle terminal voltage will be vary because this is a variable resistor, right? So if you look at the output, of the serial monitor, you can see that when I turn this, එක පැත්තකට ගියාම 0 කියලා එනවා. අනිත් පැත්තට කරකව ගෙනියද්දි ඔම යද්දි දැක්කද? වැඩිම value එක 1023 වෙනකන් එනවා. හරිනේ? බලන්නකෝ කරලා. Again I will show you what to do. The same code in this, our previous code is used to measure the voltage of A0. Now A0, analog pin 0, is connected to the middle of the middle of the variable resistor. So variable resistor is connected to 3 rows of the breadboard. Middle one is connected to A0. දෙපැත්තේ ඒවා දෙක, ඒ දෙක connect කරන්නේ positive and negative voltages වලට. කරලා බලන්නකෝ. කල්ල ඉවර කරන්නක යෝරනාම කියන්න. හරි අපි බ්‍රේක් එකක් ගමු. බ්‍රේක් එකක් අරගෙන ඊට පස්සෙත් අපිට ඇනලොග් ඉන්පුට් එකත් එක තව වැඩ කරන්න තියෙනවා. බ්‍රේක් එකක් අරන් ඉමු. Okay? 10 minutes වගේ බ්‍රේක් එකක් ගමුකෝ. Now the time is 10:20 10:00 10:35 විතර පටන් ගමුකෝ. Okay, we will start. So what we did was just using analog port, analog port of the Uno board. It is always an input. Analog set එක මෙතන තියෙන analog set එක ඒක හැමතිස්සෙම input විදිහට තමයි අපිට use කරන්න පුළුවන් වෙන්නේ. Analog read is the function. So by using analog read function, we can read the value. So it will be in the range of 0 to 1023. 0 to 1023. When the input voltage is 5 volt, value will be 1023. When the input voltage is 0 volt, value is 0, right? Here we use a variable resistor, and by varying this one, we can change the voltage, right? So we are going to use the same circuit and all here. මේක කරන්න පුළුවන් වෙන ක්‍රමයකුත් තියෙනවා. There's a function called map. There's a function called map x to y. එහෙමත් පුළුවන් මේක කරන්න. Because always we have to convert one set of value to another set of values. So you have to put 0 to 1023. Okay, I will explain the map function later. Don't worry. Right, we'll keep the program as usual. Now what I'm going to do is I'm going to use two variable resistors, two 220 ohms resistors. And I'm going to connect them serially. Two variable resistors connected serially, right? One end is connected to one side is connected to 5 volt. Yellow color. One is 5 volt. Okay. Other end is connected to ground. 5 volt ground. Serial connection. Analog input is the middle one. You know that now these voltages are divided now. So if you check the serial monitor value, serial monitor value, it is should be 2.5 volt, but we'll see what is the value. උඩටම connect කරොත් 5 volt. උඩටම connect කරලා තියෙනකොට 5 volt. මැදට connect කරොත් ඒකෙන් භාගයක් එන්න ඕන. 2.5. පල්ලෙහාට connect කරොත් 0 කියලා එන්න. This is 0, 2.5. උඩටම connect කරොත් ඒකෙන් භාගේ 5 volt. බලන්න මේ setup එක හදාගන්න බලන්න. මැදට තමයි analog input එක දීලා තියෙන්නේ. මොකද මැද equal resistors දෙක ගන්න මෙතන තියෙන්නේ. These two resistors are equal resistors. Therefore, voltage is also equally divided. Therefore, voltage at the middle is half of the supply voltage. Half of 5 is 2.5. Hope that you have done this right. හරිනේ ඔක්කොම ඔය කට්ටිය වැඩේ කරගෙන තියෙන්නේ. Next you have to find the LDR. Find the LDR and 100 kilo ohms resistor. All of you. Find the LDR and 100 kilo ohms resistor. Hundred kilo ohms for brown, black, yellow. Third band is yellow. Brown, black, yellow. මේ දෙක හොයාගන්න LDR එකයි මේ resistor එකයි හොයාගන්න brown black yellow එක. Right, today we are going to construct a dark sensor circuit by using the Arduino board. Okay, our objective is that. So what we have to do is, instead of these two resistors, we have to use the LDR. We have to use the LDR and the 100k resistor. So in my case, I have connected the LDR to the 5 volt end, but you can connect it into any end. 5 volt පැත්තට තමයි LDR එක දැම්මේ. ඩාර්ක් වුණාන් පස්සේ voltage එක වැඩි වෙනවනේ. Clear? One of the resistor is LDR, other resistor is 100k. So these two are connected. මේ ඩාර්ක් කරාම මේ resistance එක වැඩි වෙනවා. ඒතර ඒ උඩ voltage එක වැඩි වෙලා යට voltage එක අඩු වෙනවා. Okay? So if you look at the serial monitor now, if you look at the serial monitor, right? When we set it to dark, now I have set it to dark, then value of X is 700 something. But when we expose it to light, it is 900 something. Can you see? This can be varying from LDR to LDR or the background light that you have. The මගේ case එකේදී මම 100k එක ගත්තේ. මේක හොඳට මෙහෙම වැහුවම් පස්සේ මේ dark කරන් පස්සේ මේ බලන්න මේ අගය එන්නේ එක ගන්න. හොඳටම dark කරොත් නම් 100 ගණන් වගේ වෙනවා. මේ අපි ඉතින් සාමාන්‍යයෙන් dark කරන් පස්සේ ඔය 500 ගණන් වලට වගේ එනවා. දැන් light එකට ඇල්ලුවම් පස්සේ 700 ගණනක් වගේ වෙනවා. මගේ තත්ත්වය එහෙම 900 ගණනක් වගේ. Right? So what I want to do is, when it is dark, it is less than 900 in my case. Dark වුණාන් පස්සේ LED එකක් පත්තු වෙන විදිහේ කෝඩ් එකක් ලියන්න හදන්න. So I'm going to use the same code there. X වල value එකෙන් තමයි අපි දැන් වැඩේ කරන්නේ. Right? So if X is less than 850, that is my value. Digital write. What? 13 to high. Else digital write. අර inbuilt LED එක තමයි අපි මේ use කරන්නේ. Digital write 13 to low. Okay, that is my plan. So I'm going to use inbuilt LED. Therefore, I have to use pin mode 13 as an output. Okay. මේ 850 කියලා මම දැම්මේ මගේ experimental value එකත් එක්ක. You have to use your experimental value. දැන් මම code එක upload කරලා තියෙන්නේ. Semicolon missing. Okay. පාට මේ 850 කියන value එකම දාන්න අවශ්‍ය වෙන එක නෑ. You have to use the suitable value according to your environmental conditions, right? Ambient condition කියලා අපි ඒකට කියන්නේ පරිසරික තත්ත්වයන්ට. So I can see when I set it to dark කරාම inbuilt LED එක මේ හත් වෙලා තියෙනවා. If I release this එහෙම dark කරන්න pen clip එකක් වගේ එකක් දැම්මම වැඩි හොඳයි. Now dark. නැත්නම් මගේ මේ lights මම off කරන මෙතනින් light off කරනවා. light off කරත් තව light එකක් තියෙනවා පැත්තකින් දෙකකින් එළිය එනවා. ඒක තමයි dark sensing circuit. ඒක dark light මාරු කරගන්න පුළුවන් දෙපැත්ත වෙනස් කරලා. You can try it. Here I use 100k resistor. You can use a different resistor, then you can have different effects. 100k කියන එකත් එක එක්කෙනාට වෙනස් වෙනවනේ. So this is a circuit having input as well as output. LED is the output, LDR is the input. අර value එක ඔයාලට suitable value එකක් දාන්න. අපහු ඡන්දේ දාන්න වෙනවා. අර සීරියල් එකට ඔයාලට කැමති වැලියු එකක් දාන්න පුළුවන්. ඔයාලට දෙකේම එකම වැලියු එක සෙට් කරන්න විතරයි ඕන. You have to both same value in both sides. 9600 නම් දාන්නේ දෙපැත්තෙම 9600 දාන්න. That's it. කල් ඉවරන පෝල් එක දාන්න. Okay. So far we have discussed how to use the digital port. Hmm? How to use the digital port. Digital port we use both ways. As an output, earlier we use it as an output, then later we use it as an input, right? Today we learn how to use digital inputs. Also we learn how to use digital, how to use analog inputs. So analog input range is 0 to 1023, 0 to 1023 range. When voltage is 5 volt, 1020, that's what we discuss. Okay. Analog port only supports for analog inputs. It does not support for analog outputs. So, but there is a method. There's a method. There's a method to generate analog outputs. There's a method to generate analog outputs. I will show you this with an example first. කට්ටිය පොඩ බලන්න screen එක. Now I'm going to use pin number 13 LED. Digital write 13 high. Then put a delay. Very first program. Very first program. Okay. And digital 13 low. And put another delay. This is our very first program. All of you are familiar with this. So I'm going to upload it. Then LED is blinking. Setup එක මම අයින් කරන්න. ඒව අයින් කරන්නකෝ. LED is blinking. පේනවනේ LED එක blink වෙනවා. Here if I put very small values. There is a function delay microseconds. Micro M capital, right? Delay microseconds. Delay microseconds. That means you can have to put the micros. මේකම ගන්න නම් එතකොට තව 1000ක් දාන්න ඕන. Okay, 1000 දාලා හරියන්නේ 1000 තව 1000 දැම්මම පස්සේ තමයි අර විදියට එන්නේ. That's another delay function. Milli micro. Something wrong. Okay, first we'll use delay function, 10 10 10. Just look. අපි අර කලිනුත් මේක කරලා පෙන්නලා තියෙනවා ඔයාලට. Now delay is 10 10. So you know this LED is on and turning on and off, but you can't see. Now see, LED is on, but brightness is low. Brightness is low. Brightness එක ටිකක් අඩුවෙන් පේන. Brightness වැඩි කරන්න බලන්න. පොඩ්ඩක් brightness එක වැඩි වුණානේ. You can see that LED is on. But actually, what is going on is not on. I'm going to turn the LED to high for 10 milliseconds. Right? Then delay is 2 milliseconds, 2 milliseconds too low. Right? Then මෙතන මෙහෙම අපි හිතුවොත් මේක 0 කරමු. Let's say this is 0 and this is 10. Then that means delay time is there is no any low time. It's almost high. Therefore, if you look at this situation, now LED is in its full brightness. අපි මෙතෙන්ට මෙහෙම එකක් වගේ දැම්මොත් then LED brightness will be low, little bit low. පොඩ්ඩක් low වෙනවා. ඒක ඇත්තට මේ කැමරාවෙන් බැලුවට පේන්නේ නැහැ. අපි එහෙම කරමුකෝ. මේකට 5ක් දාලා මෙතෙන්ටත් 5ක් දානවා. Half half. So half the time LED is on, half the time LED is off. Therefore LED will be half the usual value. What we can do is we can on the LED for 1 time and 9 times LED is off. Right? So if you look at, you can see that LED is a very low light operation now. One LED එක එළිය ගොඩක් අඩු වෙලා තියෙනවා. අන්න එහෙම එකක් අපිට කරන්න පුළුවන්. ඒ වගේ එකක් කරන්න පුළුවන්. බලන්න මම පොඩ්ඩක් බෝඩ් එකෙත් මේක ඇදලා පෙන්නන්න හදන්න. Time. Now 5 times LED is on. 1 time LED is off. This is 0 volt, this is 5 volt. This is digital 13 output voltage. The mega on off වෙනවා. But you can't see it is on and off. On off වුණාට ඒක අපිට එච්චර පේන්නේ නැහැ. 50 Hz වලට 10 Hz වලට වඩා වැඩි වෙච්ච ගමන් පේන්නේ නැහැ. අර අපිට පුළුවන් මේ on වෙලා තියෙන වෙලාව අඩු කරන්න. මෙන්න මේ ටයිම් එක අඩු කරන්න පුළුවන්. අඩු කරන්න පුළුවන් මෙහෙම. මේ ටයිම් එක මෙතෙන්ටම ගෙනිච්චොත් fully on. එහෙම අඩු කරනකොට LED එක off වෙනවා. ඒ වගේ. මේකට කියන්නේ this is called pulse width modulation. මේ ටෙක්නික් එකට කියන්නේ this is the pulse width. This is the pulse width. So pulse width can be increased or decreased. We have to do this very on and off very fast. Then we can't see it is on and off. But if you change this value, then the brightness of the LED will be reduced, right? So in Uno board, in Uno board. Look at in the Uno board, if you look at the digital port, not the analog. If you look at the digital port, මෙතන මේ වරහන් ඇතුළේ තියෙනවනේ PWM symbol. Huh? Pin number 3, 5, 6, 9, 10, 11. They are special pins. There's a separate hardware circuit to handle this called pulse width modulation. So I'm going to use that special technique to do what I did this manually. So I'm going to use a PW pin, for example, pin number 6. Pin number 6. මේ code එකට අපි දාන title එකක් විදිහට දාමු PWM. PWM. The idea of PWM is to produce analog in is available. This is the how we do analog output, analog out, right? So you have to use analog output pins, in other words PWN pins. In the Uno board, the PWN pins are 3, 5, 6 බලන්න පේනවනේ 9 එක එක බෝඩ් වල එක එක පින් තියෙන්න පුළුවන්. ඒ කියන්නේ නැනෝ බෝඩ් එකේ වෙනස් වෙන්න පුළුවන්. එක එක ඒවට වෙනස් වෙන්න පුළුවන්. There are 6 PWM pins in the Arduino Uno board. So you have to use one of the PWM pin here and set it as an output, right? So you have to go not the digital right now. It is analog, right? Analog, a simple analog, right? Which pin that we want to set? We want to set PWM pin, analog right 6. Then not high low. You have to put a value. You have to put a value in between 0 to 1000, 0 to 255, 255, 255 delay of 100. 1 second. 2 seconds. Similarly, I'm going to use different values. දෙසියට දානවා 150ට දානවා 50ට වගේ දානවා 0 වගේ දානවා. So you can, with the analog write function, you can put values 0 to 255. අර ඉස්සෙල්ලාවේ 0 to 1023 වගේ ඒ වගේ ඔයාලට පුළුවන් 0 to 255 values දාන්න. And I'm going to upload this code. Okay, and this is restarted. You can see the brightness of the LED. Tick I didn't upload. So it is uploaded. Not the, this is pin number 13, no? So with pin number 13 we can't do this. Pin number 13 is not a PWM pin, so we have to use separate LED. At the moment I have used digital 6, no, right? එකට මේ 220 එකට වැඩි ටික වැඩි එකක් ගන්න පුළුවන් නම් හොඳයි. මොකද 220 එක ටිකක් අර ඕනට වඩා වැඩිනේ. මම ගාව 220 එකක් තමයි ළඟ තියෙන්නේ. I will use 220. එක පැත්තක් අපි කනෙක්ට් කරනවා PWM pin එකට. එක පැත්තක් අපි කනෙක්ට් කරනවා PWM 6 එකට. inbuilt LED එක නෙමෙයි අපි use කරන්නේ. ඒකේ වැඩේ කරන්න බෑ. At the end is connected to the ground. Let's see, brightness off, full brightness. අර චුට්ටක් අඩු වුණානේ. අපර දෙකින් දෙකට brightness එක අඩු වෙනවා. විතර මේ LED එක එහෙම තිබ්බට මේක on off වෙවි තියෙන්නේ. මේව. on off වෙනවා. fast එකේ වෙනවා ඒක. අර මම අර ඉස්සෙල්ලා කරලා පෙන්නුවේ. පොඩි delays දාලා. This is getting on and off very fast. Okay? But we can't see that is on and off. අර එක එක වෙලාවෙදී on වෙලා තියෙන වෙලාව වැඩි කරනවා. If you put 255 to the analog right, that is the highest value. හරි බලන්න මේ LED එකක් externally connect කරන්න ඕන PWM pin එකකට. කරලා බලන්නකෝ. I have shared the code. It's a high value. 0 is something like low. Metal 5 volt. Then you can 0 volt. You can only use this with PWM pins. Analog port එක අපිට use කරන්න බෑ. අප්ඩේට් එකක් දෙන්නකෝ වැඩේ තේරුණාද? So we can't use analog out, right? There is no any analog out here. Analog pin port only support for inputs. Huh? Right. I'm going to change the code little bit to have better output. All of you. So I'm going to use a variable. Uh, variable, let's say A. A is initially 0. So I'm going to put A here and delay is just 100. Okay. See what happened? And I'm going to increase A. A is A plus 1, A plus 5. Okay. So if you reach to the maximum value, if A is greater than 255, because 255 is the limit, again, I'm going to set A to 0. Hope that this is clear. You see what happened now? A කියන එක තමයි 0 තමයි මුලින්ම එන්නේ. ඊට පස්සේ 5 එහෙම 5 add වෙවි යනවා. If you look at, you can see some visual. well අර එළිය අඩු වෙලා එළිය වැඩි වෙනවා. මේ වැඩි වෙච්ච ගමන් ටක් ගාලා මේ අර එළිය අඩු වෙලා වැඩි වෙනවා. ඊට ඕන එක හැමීට වෙන්න දාන්න පුළුවන් ඩිලේ එක වැඩි කරලා. මේ බලන්න. මේ වැඩි වෙනවා. වැඩි වෙලා පිටලා එක පාට 255 වෙච්ච ගමන් ආපහු ලෝ එකට යනවා. බලන්න try එකක් දෙන්නකෝ කරා. code එක මම share කරන්න. Okay, I have to teach you two more things today. I have planned to teach you two more things. One is use of okay. One is use of some logical operations, and also the complete the discussion about the pulse width modulation. Okay. So before moving to the completeness of the pulse width modulation, I will explain you a few more coding things. Okay. Right. So look at the code that I have shared earlier. So here what happened is uh, analog write. We are going to write 0 at the beginning. So A will be 0. Then 0 plus 5 is the value of A. That means next value will be 5, then 10. Likewise, the values are gradually increasing up to 255. 255. When it reaches to 255, above 255 again it's set to initial value. Therefore, suddenly LED turn off. Okay, tell LED is initially LED off, and LED is gradually increasing its brightness. When it reaches to the maximum, suddenly going down, right? So I'm going to add more code in here. So instead of 5 here, I'm going to put B. Okay, and B is also an integer. B is also an integer. B is 5. Same thing, no? Okay. So if A is greater than 255, I'm going to set B to -5. If A less than 0, then B equals 5. Try to understand this. Try to understand this. තවම වැඩි වෙනවනේ B ගන්න ඇඩ් වෙවි යනකොට 255 වෙනවා. There's an instant where A is more than 255. Then what I'm going to do is I'm going to set B to -5. Now B is -5. Therefore, we are going to add -5 to A. Therefore, value of A will gradually decrease now. ඉස්සෙල්ලා පහ පහ එකතු වුණා. දැන් පහ පහ අඩු වෙනවා. Again, there's a condition. If A is less than 0, 0 වලටත් එනෝනේ ඇවිල්ලා. අන්න එතකොට ආපහු B 5 කරනවා. Right? So what happened is some cases B is 5. Some cases B is -5. තේරුණාද? දෙකට equal දාන්න එතකොට වැඩේ ලස්සනට වෙනවා. බලන්න. බලන්න දැන් වෙනද brightness එක වැඩි වෙනවා අඩු වෙනවා වැඩි වෙනවා අඩු වෙනවා හරි කල් බලන්නකෝ I have introduced b here b කියලා තව variable එකක් අරගෙන තියෙයි I will put it into the chat too status එක update කරන්නකෝ because we are going to write this program in a different way now okay today we are going to learn little bit of programming too that's right today we learn if statement no Hmm? Today we learn if statement in Python, in C language, in Arduino, that means C language, if statement. You have to put if, then within the bracket you have to put the condition and put the statement under the if. Then you go to else and the right. So look at the code here. What I'm going to do here is something like this. If A greater than or equal to 255. These two lines are used to say O. A less than or equal to 0. This is my condition. My condition is made by using two conditions. Then combine color in O again. Okay. What I'm going to do is B equals minus B. B equals minus B. B will be the minus value. So think that initially A is 0. No? මේක O එකට පාවිච්චි කරන්න. O කියන්නේ දෙකෙන් එකක් කියන එකනේ. So initially A is 0, B is 5. So A is added to B. Therefore 0 plus 5. Then 5 plus 5. Likewise A is increasing. A is increasing. There is a situation where A reached to 255. When A is 255, what happened? When A is 255 O, එතනට මෙහෙම equality එක කොහොම තිබ්බත් ඇති. හරියටම 255 වෙන හින්දා. When A is 255, what happened? When A is 255, B is minus B. What is the current value of B? B is 5 now. So B is 5, therefore B equals minus B. Therefore B will be minus B. When A is 255, A එක 255 වුණාන් පස්සේ B වලට එන්නේ ඍණ B කියලා. ඒ කියන්නේ ඍණ 5යි කියන. එතකොට ආපහු it will repeat with minus 5. That means A will be reducing. A will be reducing and ආපහු එනෝනේ A වලට 0. Then B equals minus B. What is the current value of B? Current value of B is minus 5. So minus 5, it will be plus 5. දැක්කද? ඍණ ගාන තිබ්බ එක ඍණෙන් ආපහු වැඩි වෙනවනේ තර ධන වෙනවා. තර 255ට වෙනකන් තිබ්බ එකේ ඍණාගේ වෙනවා. දැන් ඍණ 5 වෙනවා. ආපහු ඍණ 5 ධන 5 වෙනවා. ඒතර එහෙම ඒ විදිහටත් ඍණ 5යි ධන 5යි අපිට මාරු කරන්න පුළුවන්. ඔයාලට අර කෝඩ් එකම තමයි මේ තියෙන්නේ. Speciality is I have used O මෙතන O එක use කරලා තියෙනවා. Right? So I will show you a language reference page. මේක මේ Python Arduino වලම මේ තියෙනවා මේ language reference කියලා එකක්. හරි? ඒකේ තියෙනවා මේ ඔක්කොම operations. Here I use the Boolean operations. So these are the available Boolean operations in our Arduino programming language, right? To use O, you have to use the O vertical lines, vertical line, vertical dash or vertical slash twice. If it is AND, you have to use AND symbol twice. If it is not, you have to use the exclamation symbol at once. Okay, that's how basic operations are for. Okay, you can try this code also. Here what I want to explain is the O. This is O. Okay, O is used. You can try it. අර විදියත් හරි මේ විදියත් හරි. Here the speciality is we use logical operation or operation. Okay, so there are several such operations. මේ දාන්නේ O and දෙපාරක් දාන්නේ and එකට and exclamation mark used for not. Just confirm if you have completed this. Okay. Okay. And the last thing is the PWM part. Okay. Pulse width modulation part. So if you turn to the page 4 of practical number 13, at the beginning you can see the PWM note. Practical 13 කියලා තියෙන්නේ day 13 එකේ ඒකේ තියෙනවා මේ practical 8 කියලා එකක් pulse width modulation කියලා. එතෙන්ට පොඩ්ඩක් හරව ගන්නකො. එතන මේ රූපේ පොඩ්ඩක් ඇඳ ගන්න ඕන. PWM practical 8 එකට යන්න. practical 13 අද කරන sheet එකේ ඒකේ practical 8 එකට යන්න. එතන heading එක දාලා තියෙන PWM කියලා. Analog. Right. Here you have to put the PWM pin. Then here you have to put a value. It's a function. So what happened is, let's say PWM pin is 6 and this is 100. Then digital pin number 6 will operate like this. 100 of time is set to high volt. The total time is 255. Again, same thing. 100 of 255 of time. That's my timing. This is happening very fast. I can't remember what is the frequency here. So this is the situation. The පොඩක් දාගන්න. මේ width එක තමයි අපි control කරන්නේ. This pulse මේ එකකට තමයි pulse එකක් කියලා කියන්නේ. Pulse width එක තමයි අපි එකෙන් control කරන්නේ. This is 100. So it's 100. Okay, මේක පොඩක් ඇඳ ගන්න practical 8 කියලා තියෙන තැන මයිඩ තියලා තියෙන. PWM pins ටිකත් බෝඩ් එකේ බලලා ලියා ගන්න. PWM pins වලට දැන් 6 පාවිච්චි කරන්න පුළුවන්. ඒ වගේ හැම වැලියු එකක්ම පාවිච්චි කරන්න බෑනේ. 3, 5, 6, 9, 10, 11. හරි මොන හරි ප්‍රශ්න තියෙද පැහැදිලි නැති තැනක් තියද? So today mainly we discuss the practical number 12, last page of the practical number 12. Okay, this is practical number 13 no? So it's practical number 13. We started with practical number 12, the last page of the practical number 12. Again, practical number 13, first page, we have done. Practical 1 we did. You can try practical number 2 later, right? And you can see more outputs there. But I did not go through the page 2, practical 3 and 4. So next time we are going to do it. It is also serial communication in other way around. And we discuss page 3 and page 4. Page 3 is about analog inputs and voltmeter, and the dark sensor, light sensor, and the pulse width modulation, right? අර මේ තමයි අර අපි කලින් ලිව්ව කෝඩ් එක. හරි. fade in එක. So you can try the practical 10 as a homework. In the practical 10, what I have done is just look at, you have to use variable resistor. So variable resistor is connected to the analog port 0. Okay, it values then varying from 0 to 123 no. Then pin number 9 is a PWM pin. Okay, pin number 9 is PWM pin. Analog write can be used now. Then we are going to put this value output. So output is obtained by using the input. Input means the variable resistor. Variable resistor then in 0 to 1023 ne. ඒක අපි 0 to 255 වලට map කරනවා by using map function. මේ විදිහට කරන්නත් පුළුවන්. ඒකම map function එක දාලා කරන්නත් පුළුවන්. හරිලා? එතකොට brightness එක අපිට control කරගන්න පුළුවන් variable resistor එකේ. ඒ කියන්නේ මේකේ තියෙන්නේ අර දෙකම තියෙනවා. Analog input as well as analog output. Practical 10 is a program having both analog input and analog output. එක ඔයාලට නිකන් try කරලා බලන්න පුළුවන්. අර variable resistor එක connect කරන්න analog 0 එකට output එක අරගන්න පුළුවන්. ඒ දෙක connect කරලා you can control the brightness. කරමුද බලන්න ඒකත් අහනවා. First I will show you the setup. Simple වැඩනේ setup එක මම පෙන්නන්න. අපි variable resistor එක ගන්නවා. ඉතින් variable resistor එක. variable resistor එක පැත්තක් අපි 5 volt වලට connect කරනවා. 5 volt වලට connect කරනවා එක පැත්තක්. 5 volt වලට connect කරනවා. අනිත් පැත්ත අපි ground කරගන්නවා. මේ board එකේ තියෙන ground එක ගන්නත් පුළුවන්. board එකෙන් ground කරගන්නවා. මැද තියෙන pin එක තියෙන. මැද pin එකනේ අපි signal එක ගන්න. That one is connected to the analog 0. Okay, 9 එකට code එක ලියමු. හින්දා මම 9 එකට connect කරගන්නවා. මේ code එක අපි upload කරනවා. Okay, මෙතනින් අපිට කරකවනකොට මේ brightness එක අඩු වැඩි කරගන්න පුළුවන්. This is analog input. This is analog output. Analog output is obtained by using PWM. Analog input is connected to the මේ විදිහට අපිට brightness එක අඩු වැඩි කරගන්න පුළුවන්. ඔයාලා කරලා බලන්න ඒක. හරි. අර දෙකේ combination එකක් තමයි ඒකේ තියෙන්නේ. Right? Now almost we have completed the basics of the Arduino. Okay, basics of the Arduino. That means how to use the digital port and how to use the analog port, how to provide uh, how to use PWM pins. And also we have to discuss about serial communication more in more detail. We only know how to send certain messages to the computer monitor by using the Arduino board. From Arduino board, you can send, this is Arduino board, from Arduino board, you can send messages to your computer. The other way is also possible. From computer, you can send messages to the, Arduino board, and Arduino board can be controlled by using your computer in that method. So next time we are going to look at it, and also we are going to look at how to use more components, right? Okay, we will stop here. Next time we are going to look at more programming and more about the serial communication. Okay, bye.